Hello and welcome at this short demonstration of VxWORKS 7 running in 64-bit mode. For this demonstration I'm using a Freescale T2080 processor mounted on a Curtiss-Wright VPX3-133 board. It's a 3U VPX mount. It's nice and compact, and you can see it on the left hand side of my screen here. It has 8 logical cores, 4 physical cores, and I'll show that during the demonstration as well. You can see here I've got 2 cables connected beside power naturally. One is the serial cable and the other one is Ethernet. So I can just dive into this demo right away. I've booted VxWORKS already. I took the liberty of doing that. And you can see here it's VxWORKS 7 SMP 64-bit. So the operating system runs all across these 8 logical cores. And you can see that here as well because I have an 8 CPU count and I have 4 gigs of memory. If I look at my task table, you can see that all of the relevant fields are 64-bit. So the task ID is 64-bit and the program counter is also 64-bit. And then if I step one layer deeper, I can actually look into these tasks and can do a task show of that 64-bit address. And then you see that the information here is also 64-bit information. So these are 64-bit registers for all of the processor registers. And then I can look into things such as address space show, which gives me more information about the address that the operating system has access to. And in this case, you can see that there's indeed about 4 gigs worth of total physical memory, but that you can actually address up to 8 terabyte of kernel virtual space. So lots of space to work with here. It's a fully fledged 64-bit operating system. And with that 64-bit operating system, you get all of the facilities that you would expect from a real-time operating system, from a command line, building, debugging, but also analysis tools. And that's what I wanted to show you here. I'll make a quick step into the debug tools, and then we'll go into the analysis tools. Before I go there, I do need to quickly set up my IP address, which I hadn't done before. There we go. And then I need to start my debug agent. That is it's a function call. You can also configure this automatically. And that's it. Then I can connect my debugger. And once the debugger is connected, I can then download my applications and debug them automatically. So I'll use the standard VxWORKS Workbench Cafe Top demo example. So I can run my kernel task and it'll attach the debugger, break at the entry point. So that'll download it, start the function, but then immediately stop it as well. So here you go. Debugger is paused at this breakpoint here, and I can do step in, step out, all that good stuff. Look at variables. But that's not what I really wanted to show you here. I want to show you the analysis tool. So I'll start this application, and I'll start what we call the analysis tools here. I'll start with a CPU profiler. It shows you how much processing power is actually being used, and you can already see that here at the bottom. And then there's multiple different views here that you can use. One is the history view that shows you a graph of these CPU cycles being consumed over time. There's a table, and there's a call tree analysis. And the table goes over a specific range of time. You can see the time up here. So at this point in time, it's from start to now. And you can see these tasks with CPU percentages. But as I said, this is a multi-core CPU. So maybe I actually want to show this aggregated by core ID, and now I can show you which cores these tasks are actually running on and how much percentage they use on each of these cores. And then this is all great, but now I'm looking at 8 cores at the same time. That's a bit much. Maybe I want to filter this and say I only want to look at core number 2, and then voila, now I'm only looking at the threads and tasks on that core number 2. So very convenient to quickly navigate. In this case, we're just looking at processor cycles being used, but I can actually add other metrics as well. I can add metrics, anything having to do with kernel memory, freed or mallocked, interrupts that come in, memory usage, packets that come in, semaphores, lots of stuff that I can look at and see how many system resources my application is actually using. And then let's go back to our unfiltered view here. Then on the bottom here, I can see how this maps out in a code view as well. So I can look at my task entry here, and I can see, for example, this fraction spin is taking up some processor times. And here you can see how much time is being taken up by what type of functions. So in my code view, I can see, oh, wait a second, the while here is actually taking up a lot of time. And then my tree_a function is also taking up some significant time here. So a really good way of quickly looking at the consumption of your system. If I stop at this tool first, I can switch to other analysis tools. There's a system overview as well that kind of blends a whole bunch of these views together. Again, I have my tasks, I have my viewer here, and I can see again my core usage, but now it automatically blends in kernel memory, I/O, as well as networking packets that are going through. So a nice, concise, easy way to quickly get a grasp of your 64-bit system. So that's what I wanted to show you today. Short demonstration, as I said, VxWORKS 7 running fully 64-bit, 64-bit memory spaces, 64-bit addresses, 64-bit registers. Of course, debugger is available as well. And then these analysis tools, which quickly allow you to figure out what's going on with your system. Thanks for watching and have a great day.